Hello guys, I'm Justin. I'm going to show you how to solve the longest string chain problem. The intuition behind this problem is we are given an array of strings and we return a count of the longest chain. So what is a chain, you might be wondering? A chain is basically you can see it's a word that contains the other characters. So for example, you can see A is inside AD is inside DAG, and DAG is inside GDAC. So another thing you might notice about these is they're in random order. So they don't necessarily have to be in the same order, but the important characteristic in this problem is that each of the characters are in the part of this chain. So you can see B is not part of the chain, so this returns a count of 4. So taking you through this problem, like how is it solved, I want to convey before we jump into the coding exercise. There's 4 important principles. So the first thing you need to know is we need to use a set. So we will first of all we're going to loop through this array, and then we're going to put each of these strings into the set. We use this for very fast lookup. The second thing you'll want to initialize is you'll want to initialize a map, and the map contains the key of the map is the particular string. So, an example, A is a key and GDAC is a key, and the values that will eventually become assigned to this map are the final counts. And then the third thing is we will create word permutations. And this is done inside the recursive function trace. So trace is a recursive function, and it will be called with 3 parameters. The first will be the set, the second will be this map, and the third will be the word. So in this, when we program this, the first thing we'll do is we will first of all create a loop, piping in each of the strings into trace. And then trace will in turn call trace with a permutation. So what is it? What is a word permutation? Focusing in on the string AD, the 2 permutations for AD are AD and DA. So those are generated. And why do we generate those? Well, we generate those because I mentioned part of the problem or complexity of this problem is the fact that the order of the characters, it could be in random order or it is in random order. So we generate all the word permutations. The second thing we do then is we will check to see whether or not the permutation exists in the set. So this is the purpose of using the set. You can see AD does in fact exist within the set. And then the final thing we'll do within trace is we will call trace with each of the word permutations that exist within the set. And then we will increment the counter. If in fact you'll see the condition that we are testing against, and then we return the final count if in fact it's a sequence. So let's jump into the code and you'll see how this works. Go implementation of the problem. You can see that first of all Go doesn't have a set data structure, so I just simply use a map mapping a string to a struct, and this takes care of the functionality we look for the set. I implement a add function and a contains function, and you can see here this is the function that's called by the tests. It's called longest string chain. It passes a string, a list of strings, and then we initialize a set, passing in words to the set, and then we create the map of that's basically the counter mapping the string to the integer. Initial count is 0, and then we loop over the range of the words, passing in the count, and then actually this is a max function. So we take the max of either the greater count or the traced word. And then we get a count for each word recursively. So trace is called with the set, the map, and the current word, and then of course we return the count. Trace down here is where things get interesting, like I mentioned. First thing we do is we check whether or not the word has already been explored, and if so, we simply return the count. That's it. Then we have a temporary variable, which is the max length. We loop over the length of the word, and then we generate here all of the permutations. So one permutation at a time, we see whether or not the set contains the permutation. If it does in fact contain the permutation, then we take we recursively call the trace again, and we assign the max of either the previous max length or the result of the trace. And then down here we increment for each word the max length, and then we simply return. So recursively, this will generate the solution. The tricky parts to this, of course, I thought the trickiest part in implementing this was generating word permutations. So you want to focus in on here. And the second tricky part was the fact that Go doesn't have a native set data structure, but that was easily taken care of with this new type. Let's go run main test. I wrote a test. Whoops. Go test. All we do is go test. It passes. I'll show you what the test contains. The test contains initialize in, which is a slice of strings, which contains the 5 different, or the, what is this? 1, 2, 3, 4, 5, 6 different strings that we went over, and then the counter, and then we have we verify that the count is in fact 4. That's it.